The anatomy of melting chocolate. Have you ever wondered what mechanisms occur when chocolate melts? Why does chocolate have this chocolatey smell when opened? Let us find out through this video. I have this frozen Goya dark chocolate fresh out of the fridge. I cut a small portion of it and place it under a flashlight and behind the laptop's up air. Let's see what happens. As you can see, the chocolate was rock hard. After several minutes, the chocolate starts to soften. This is due to heat transfer processes such as convection and conduction. Convection from air in room temperature to the cold surface of the chocolate. Conduction from the plate to the chocolate. Conduction, since behind this plate, hot air flows from the laptop's fan cooler towards the plate. The plate conducts the small amount of heat towards the chocolate. As time goes by, the accumulation of heat from convection due to air in room temperature and the conduction of plate increases the temperature of the chocolate. In this part, the chocolate becomes softer compared to its initial state. This process melts the chocolate until it forms a liquid-like substance. However, this liquid-like substance is not present in this video since the heat required for this phase to occur was not met. It was only partially melted, as seen on this part. Both of these heat transfer processes is driven by temperature difference between the chocolate bar and the room temperature and the temperature of the plate. The required parameters to determine the rate of heat transfer would be the area exposed to air, the initial temperature of the frozen chocolate, the room temperature, the temperature of the plate, thermal conductivity, and the heat transfer coefficients. For the next question, have you ever wondered how chocolates produce this chocolatey smell? The process is governed under the principles of mass transfer. The volatile components of chocolates produce this iconic smell. As these volatile components start to volatilize, these vapors try to diffuse and occupy the entire room. Because these molecules or vapors try to occupy the entire room, the smell that the molecules bring with it can be smelt by the nose. The driving force for this process is due to concentration difference in the room. The volatilized components of chocolate tries to occupy the entire room until the room has uniform concentration of these components, since molecules move from higher concentration to lower concentration. For this case, from the chocolate to the room. I think the parameters to determine the rate of mass transfer in this process is the concentration or the amount of the volatilized component and the area of the volatilized component to be diffused to, or the room. Random observations. I tried melting both Goya and expired Toblerone under the same conditions and temperatures, and it turns out Goya melts faster than expired Toblerone. As seen on the picture and on the video, the expired Toblerone is still rock solid while Goya starts to melt. Maybe, due to expiration, Toblerone has somewhat altered its compositions which made it harder to melt than Goya.